welcome to Syntax. On this episode, we're going to be talking about the Web Audio API and the WEBMIDI API, what these things are, why they matter, and maybe some interesting things about them that you might not know. Because me personally, when I think of web audio and web MIDI, I'm thinking of maybe playing sounds or accepting input from MIDI, but you can do a lot with these things. And there's a handful of really great community libraries out there to help you make both music, but also just control things with MIDI messages. So we're going to be talking in this episode about some really interesting audio technical concepts such as sampling. We're going to be talking about MIDI in general, the types of messages that are sent, how it's sent, what it means, how we can interact with that in the browser, and then ultimately I'll be showing you some really neat demos of stuff we can do. In fact, my desk...
Play us in, Scott, will ya?
Play us in. Okay.
No, play us in.
Play us in. Is that? Yeah.
Sounds awesome.
Okay. I can't hear that, so I don't know what it sounds like in my monitor right now, but I'll be definitely showing you some of this in just a little bit. I'm building something fun with this, so I thought it'd be a good opportunity to take a time and do an explainer. But hey, if you're trying out new things in your site, maybe you're pushing it live, and maybe that new thing is broken. Maybe it takes down your site. Maybe you're getting a ton of issues on one specific thing, or perhaps I think that I have covered all the use cases that I thought I should cover in this, and it's not working. So you're going to want to use software like Sentry at sentry.io/syntax. Sign up and get 2 months for free. This software allows you to keep track of all of the errors, bugs, issues, anything that's happening in your site, fix performance issues, find out what went wrong. You even get a session replay so you can see a video of what happened. Let's say the user went to click on a keyboard on a website and it played the wrong note. I could figure that out with Sentry. So check it out at sentry.io. Wes, my man, what's happening today, man? How you feeling?
Pretty good. Excited to talk about web audio. I've dabbled in it, 3 or 4 times. Yeah, there's this app called Bebot, which is on the iPhone. I've had it for probably like 15 years, and it's generated sound, and it goes up and down the scales. And I don't really know a whole lot about music and how all of that works, so I went and built that at one point.
Oh, did you? Cool.
HTML, CSS, and JavaScript, and it was kind of a fun learning experience.
Yeah, so what that on Bebop, I believe it's the vertical, if you're holding it sideways, the vertical is the pitch, or it's the tone or something. One of them is the pitch and one of them the tone. It's kind of like a theremin and an access of how you're doing that. Yeah. I have a lot of experience with this stuff. I did a lot of music programming when I was in college. In fact, I took several years of a music programming class where I was doing like complex Markov chains to generate music, generate songs, like automatically generated unique songs every time. We were doing things using physical hardware triggers to trigger music. I built a synthesizer out of a projector, actually, Wes. That was like one of my coolest projects. What I did is I projected, this is actually a really technical, like interesting way that I solved this. I projected color beams of different color onto the wall. So let's say there's like 6 different colors, red, whatever. And I projected that, and I had that image saved of what that should look like. And then I had a video camera pointed at that, and using Max MSP, I was able to overlay the two. So I had what the video was showing of the projector plus what it should look like. Mm-hmm. And I was able to do if one of these color beams suddenly has a difference of enough threshold, then fire a MIDI note. And that was sent to a controller to play a sound at a certain tone. So you could run through this thing and it would sound like you're dragging your hand through a keyboard. It was probably one of the cooler projects that I put together. So
that would be a fun Canvas project if anyone's looking for something, is take a video and then figure out, you probably just use the XY coordinates of the person's hand, or you could overlay it if something is breaking up a specific color.
Yeah, well, let me tell you, I even did a theremin, which you don't know. Theremin is used by like radio waves, I believe, and you put your hand into it, and it detects where your hand is, and you go.
Yeah, that's really cool.
I made one of those with my webcam, and I did video tracking. So I would hold up a little color square, and where I put it and how big the color square got, I had like a 3D dimensions of being able to tweak both the audio, the quality, the timbre, all that sort of stuff. So I was able to make noises with my webcam just like that. So long story short, I've been experimenting with just tech and music, the intersection, for a long time. And actually, since getting into web stuff, a lot of that kind of fell off for me for no reason in particular. I just became less interested. But more recently, I've been getting back into some of this stuff. And the web audio APIs that exist are really fantastic for a number of reasons. I had used the web audio API to do audio synthesis. I'd done media recorder. I've done kind of like things here and there, but I haven't really dove into it until somewhat recently here. So we can start off first and foremost. Let's talk about the WEBMIDI API, because I think the WEBMIDI API is fairly underrated amongst folks. In fact, even people who know what MIDI is and understand MIDI might not understand what you can do with MIDI in the browser. So first and foremost, MIDI stands for Music Instrument Digital Interface. It's the way that electronic music instruments can interface with devices, computers, those types of things. And when you have a MIDI device, it is sending messages. It's sending messages to whatever the device is, and the device, the digital audio workstation, you have Logic, Ableton, those types of things, receive those MIDI messages. And those MIDI messages, unlike an audio form, like when you send a waveform, that is audio. When you send a MIDI message, it's just data. It's not even data of how it sounds. It's a few messages. And typically those messages will look like play this note, play it at this velocity, and start. Or, note on this note, this velocity.
So it's just a description of the notes and how long and how high they should play them, right?
Correct. And there's all kinds of things that people can use MIDI for beyond notes. Like I have a MIDI keyboard here, and you can do like pitch bend and modulation, which these little touch pads. Those are all sent via MIDI. Or even like being able to change volume with these knobs, that message is sent via MIDI as well. But MIDI can send, it's more than just like you think about like a key press on your keyboard. You get the on and off, but you don't get velocity, you don't get how hard you pushed it, which that's a lot of interesting information, right?
Yeah, because Better Touch Tool, like the keyboard shortcut and everything tool that I use, they have full support for a MIDI controller. And I always thought that, that's kind of interesting. People are hooking up keyboard shortcuts to their piano. And it makes a lot of sense because you can store a lot more information in a MIDI payload, I guess it's called. You're going to go into, it's 3 bytes, right?
Yes. So most MIDI messages in the typical sense you're playing a keyboard are 3 bytes. It can also be 2 or 1 depending. It can be more than that, I've heard. I don't really, if you're like a MIDI expert out there, in general, when you're working especially with like a keyboard, it's going to be 3 bytes. The status byte is 8 bits, and then the data bytes are 7 bits each. So the first message, the first number that comes in is an 8-bit byte of the status. That status typically means, if you break it down into actual binary, the first digit is telling MIDI that it's a status byte. The next 3 are telling it if it's a note on or a note off. Like you're either pressing it or you're telling it to stop, right? Mm-hmm. And then the next 4 are just simply what channel it's on. So that's the status, because you can send MIDI messages on many different channels and receive them on multiple different channels as well. That allows you to...
What is a channel?
So a channel is exactly kind of like what you think about it. It's kind of like a pipe. So if I'm sending this message down pipe number 1, in my controller or wherever I'm receiving that message, I can look in pipe 1 and I can know that this is coming for this specific thing, i.e. like you have this thing, right? It has drum pads and it has a keyboard. I can put this on one channel, and when I send a message here, it could send that in channel 1. And then the MIDI receiver can listen and say, anything that's on channel 1, that's a keyboard. And then I could send these on channel 2. Anything that's on channel 2 is going somewhere else. Maybe it's a drum, maybe it's modulating something, maybe it's changing something.
Oh, okay. I see. Yeah.
Yeah, it's like just putting things in different, you go here, you go here, you go here type of way. So the second byte is a data byte, and that's a 7-bit. And by 7 bits, it goes 0 to 127. So this is the note. So when you're playing and I hit middle C, it sends a note on, which is 0x90. And then the second byte is going to be 60 for middle C because it's 0 through 127. And then the last one is the velocity, 0 to 127. And that's also a 7-bit byte.
Can I tell you how hilarious this is? That we both got into writing binary
Yes.
within the last 7 days of our entire career. So I recently did a video on controlling my Roomba with JavaScript. I hooked up like a serial port to it. There's 3 different like motors on it. There's a spinner motor on the side. There's the actual vacuum motor that sucks. And then there's the main brushes underneath that spin. And then also 2 of those brushes can spin in reverse. And in order to send the kind of state of where you want the motors to be on, right? Because there's 5 different things. There's a million different combinations. Not a million different combinations, but whatever the permutation of that is. And in order to send that combination, you send it over in binary, right? And I thought it was so hilarious that like I have never actually written raw binary or bits and bytes like that before.
Yeah.
And here we are doing it in the same week.
It is funny because I mentioned I've been doing quite a bit with this. And at first I was trying to do everything with the bits and bytes. I was trying to like really get into the raw MIDI. I was like, yeah, I'm just going to use MIDI straight up and I'm going to be very like content with that. But the more and more I got into actually playing notes and playing scales and wanting to do like more real audio stuff with it, I realized like, oh man, I really don't want to be getting into that. What I want to be doing is just worrying more about the audio stuff. So actually, I'll share some libraries in a little bit that help with that sort of thing, because there is like music-based MIDI libraries where somebody's already figured it all out. You can say play this note and it will just play it rather than having to worry about the binary. But yeah, I got into it quite a bit. So basically what happens, like you play a keyboard, it sends a note on, that note in the velocity, and then the moment you release the key, it sends another message, which is note off. And if you want to see this in action, I'll actually share my screen here if you're watching on video. And for those of you who aren't watching, we'll just basically tell you a little bit about what's coming in here. So basically what I'm doing in this example here is I'm getting access to my MIDI inputs, and then I'm setting a function to the on MIDI message. This message, this function just receives a message. You can see that anytime I hit a key, and I know if you're just listening to this, we'll describe it, but you're getting it's a straight up JavaScript event that gives you some information. Inside of that information is a data array. It's all kinds of stuff. You have the array buffer here. You have what type it is. It's a MIDI message. You can come in here and see exactly like what exactly it's coming in from. So for instance, the device itself this is a Samson, it's just a crappy MIDI keyboard. So it tells you, hey, this is coming in from a Samson MIDI keyboard, and the input message itself comes in as message data, and that gives you the command, the note, and velocity inside of the message data.
That's cool. How does it know what the keyboard is? I'm assuming the hardware sends along like an identifier byte, and then the library looks that up.
Oh, I'm sorry. This is not done with the library. This is done with the web the MIDI API itself. So my understanding, this is not
even through a library.
Yeah, this is just the device itself sending that information to the browser. Because you'll see here in my other example that you can check to find all MIDI input and output devices on your device just by giving the browser access to MIDI.
Oh, I see. So the browser itself has a list of, similar to how you can get all webcams and microphones, you can also get all MIDI devices. Okay.
Yeah, so I have all my MIDI devices, all that stuff. Either way, that's what type of message it's sending. Now, in my more advanced example, I did use this library called WEBMIDI.js, and it's super good. I'm going to tell you that right now. If you're doing anything with this stuff, the WEBMIDI.js is well worth using instead of potentially trying to do it raw yourself, because, man, dealing with the raw information is kind of tough, especially if you're doing music stuff with this. So with this library, I'm able to do a more standard, like add event listener. So I'm listening for a note on and note off and controlled change, these types of events. And this time when I hit a key, I get a lot of information with each one, like the attack is the velocity, the release, the octave.
Attack, that's cool.
Yeah, so it gives you more information, like it's giving you the name of the note itself. Because this library is taken, it's like we're going to decode the MIDI messages into things that make sense. So if you're actually doing music with it, you'll want to use MIDI.js or WEBMIDI.js, I believe. And man, what a cool library for that.
And the velocity, or the attack as they call it here, that's how fast you hit the key. So I imagine somebody playing piano, and if you hit it very quickly, it would sound different than if it was you pressed it slowly, right?
So yeah, I just smacked it and it gave me a 1. Yeah. Now I'm going to lightly press it.
As fast as possible.
Yeah, I lightly press it and it's giving me a 0.0078. So yeah, if you're playing lightly or you want to, you can do all kinds of stuff. And it's a more advanced digital audio ways of working with MIDI, Wes, is that they're actually checking that velocity and even playing a different audio sample based on that velocity. Like you have a snare drum, and that velocity, if it's below, 0.5, it's like a recording of a tap of a snare drum. And then you hit it more, and it actually plays a different audio file, like a snap, because oftentimes what we're doing with MIDI is we're using these to control and play waveforms or generate synth. You're generating synthesizers or something like that. But typically, if I hit this and I'm doing a drum kit, it's usually just a waveform of a drum being triggered in the background. So the MIDI message is like, play this note, whatever. It's like, fire this MIDI or fire this waveform. Yeah.
That's cool.
Yeah. So MIDI, really neat, right? You can do so much with it. What I did not realize about the MIDI API is that it doesn't just allow you to receive MIDI, because that's the way I always perceived it, right? You have MIDI devices, the web browser can accept those MIDI messages, you can do something with it. But the browser can also output MIDI messages, which I found to be really super neat. So for outputting MIDI messages, your browser, just like inputs, has a set of default, or your computer has a set of MIDI outputs. And by default, it could be any number one of these things. You might not have any, to be honest, if you don't have any of these things set up. So for instance, I have my audio converter, which is my digital audio interface. That shows up here. I have the keyboard that actually shows up as a MIDI output as well. And then I have this IAC driver bus. So you can do this in Windows or Mac. I don't know the Windows way to do this, but in Mac, you go to Audio MIDI Setup, you go to Window, and you open up MIDI Studio. MIDI Studio gives you access to like an interface. You click on IAC driver, you enable that thing, and then what that does is it essentially sets up a MIDI bus on your computer that you can send audio to. So it creates a MIDI device on your computer. And by doing that, that now shows up in browser as a place I can send the MIDI. So I'm sending this MIDI to this bus. And then in another application, for instance, a digital audio workstation, I use Ableton Live a lot. You can then see the one that you created and you can use it here. So for instance, I built this keyboard synth. So if you're watching along, you can see this. Otherwise, you'll just be able to hear it. I built a keyboard synth and it allows me to do programmatic music. So what's cool about this synth here that I built is it's just sending MIDI messages, right? But these MIDI messages are actually able to do a lot more than just like a straight keyboard. So like a normal keyboard, you play the notes. But what if you could play chords? So I have it set up, anytime you play the A key, it plays an A chord. And that's sending 3 messages, MIDI messages. So if I'm playing and recording in Ableton, and then, oh shoot. This is the hard part, because you have the browser active. So let's start the recording. I hit the A key.
Yeah.
Ableton receives those messages and records them right here as data.
This is blowing my mind, because MIDI is a way to get data in and out of the browser. It's almost like a WebSocket, isn't it?
Yes. Yeah.
Like you could use MIDI as a way to pipe data out of the browser, and then you can use, like, you could probably have like a Node app that listens on for on like a local MIDI, that MIDI source that you just created. So you're sending it from the browser over MIDI, and then you could pipe it into, could be a music app like you're doing here, but it could be like Better Touch Tool, which is like custom keyboard events, or it could be like a note app that you're sending data over. It's probably, the data is limited, right? You have 3 bytes. But you could.
Yeah, and what's cool about it is you can augment it. So, for instance, when I'm hitting this key down, I'm saying, oh, play the A key, but also play the D key, also play the G, right?
Yeah.
But you can do some math on that. So I built this, what I'm calling a locked chord view. So now if I play the second row of my keyboard, it's always going to give me like a chord within that scale. So if I select a C major scale, every chord I play automatically is going to remain in the C major scale because I'm doing that math wise. And so I added some keyboard controls of this where I can change which key it is. And you can change major or minor. Also, in the normal chord view, you can modulate them. So I have a second row where I hit a chord, and then I can make it minor just by hitting a 2 key. And then I hit the 3 key, it makes it a 7th, a major 7th, minor 7th, diminished. Yeah. So you can modulate it. You can do all kinds of stuff with math just by changing the MIDI notes on the input. And then furthermore, you can use things like Ableton Live to augment it even further, where I'm piping in an arpeggiator. And let's change this to locked chord mode. And now it's playing a chord into Ableton. Ableton is spreading the notes out.
Beautiful. I'm so inspired right now. This music.
And you're just messing around with it, yeah.
This is actually fascinating to me because it's like one of these overlapping things, you know? Like there's web development, but then there's also music, but then there's also math, which is figuring all this stuff out. That's really cool.
Yeah, it's neat. You know, I think the coolest thing about it for me is that now I'm able to build like a little exploration engine where I can like, I want to build a song in D minor, and then I don't have to like memorize my hand positions because I took piano, I was a music major, I know how to play all the scales. But like sometimes I'm just like, oh, what was that scale again? Oh, I'm in a weird key or whatever. I don't play it often. My hands aren't used to that. Now I can just be like, hey, give me the 4th chord in a D major scale and not even think about what the chord is, and it just gives it to me. So pretty cool. So yeah, a lot of neat stuff going on here. Overall, I think there's a lot of just opportunity here, and I'm going to take this a little bit further and try to build something like truly that I can mess around with. I even thought about building the arpeggiator directly in the browser, and then I was thinking about it, I was like, man, Ableton does that way better than me trying to write my own arpeggiator, because then I got to write a metronome and a clock to keep it all like in sync and stuff. I don't want to get into any of that. So that's WebMIDI.
Man, now you have me going downloading a ringtone because ringtones are MIDI, right?
They were.
Well, yeah, they were. Yeah,
yeah.
20 years ago, but I always wondered about that. I'm like, how come you could just download ringtones back in the day? And it was because it was just a file with a description. So it was like a 1 KB file with a description of how to play them, and then the phone itself is the one that actually has to turn it into music, right? Which is why it sounded so funny. Yeah,
it uses the same audio engine that it uses when you pushed any of the keys, like beep, boop, boop, boop. It's using that same audio engine to recreate the songs. That's MIDI, man. It's so cool because it's small. MIDI is really small, where audio and waveforms are really big. So it's very transportable. It's fast to send. It's fast to do anything with. So one of the many cool benefits of MIDI. Let's talk about the Web Audio API, though, because this is the WebMIDI API. The Web Audio API can be used for a ton of interesting stuff, too. For instance, you can generate sounds using an oscillator. An oscillator is kind of what it sounds like. It creates a waveform, right? So you're creating like a sine wave, and then you're controlling the hertz. What is that? The frequency? You're controlling the frequency of the hertz, and that changes the pitch. So the velocity is how big the waveform is, and the pitch is how tight or wide the waveform is. And if it's a sine wave, it's going to sound one way. If it's a square wave, it's going to sound more buzzy, sawtooth, those types of things. There's all different types of waveforms you can do for that. But you can generate audio straight up in the browser using an oscillator. And I'll show you an example of that in just a second. You can also bring in sound via WAV files. You can bring in sound via the WebRTC media stream. A lot of neat stuff here.
Yeah, so one little demo I built a while ago when I was looking into the web audio API was creating a dialer with your phone. So when you hit the numbers on a phone, it goes beep, doo, doo, doo. So it turns out that all of those sounds are, and I initially stumbled upon this when I was watching a documentary on phone phreaking.
Yeah, phone
which
phreaking,
is how who was the guy that did
Kevin
phone
Mitnick?
phreaking? Kevin Mitnick, how he
But also Steve
like,
Wozniak did a bunch of phone phreaking as well. Yeah.
They blew a whistle they got in Captain Crunch, and that whistle made the same frequency that would allow you to bypass these like phone companies and whatnot. I thought it was kind of interesting. So I looked into it, and I was like, you can make any audio you want in the browser with the web audio API. And I went into the Firefox OS code base. So for those who are a little bit younger, probably about 10 years ago, Firefox launched a operating system that was meant to run on your phone.
Yeah.
And it was written entirely in JavaScript. And I was at the launch of it, and they gave us like an Android phone that had been flashed with Firefox OS, and it was really interesting. And what was cool was that you can go into the code base for Firefox OS, and you can see how they implemented all the like native apps. And one of the native apps was the dialer, literally dialing stuff. So I went into it, and they have an array of the frequencies that are needed to play, because when you press a button on a dialer, it actually plays two frequencies at once, and every single number has a different frequency, and that's how that data can be sent over the phone. And I just I re-implemented it in, I don't know, maybe 20, 30 lines of code of JavaScript. It's just creating two oscillators and then setting the frequency of them when you press down, and then when you let go, you turn them off.
Yeah. So I don't know if you'll be able to hear this because it's in the browser. Maybe turn on my... Maybe that will help. So basically, for those of you watching, I have some code on the screen. For those of you listening, I'll describe it. You create a new audio context with window.audio context. Then you create a new oscillator with audio context.create oscillator. So that creates essentially your oscillator. You set what type it is. Is it a sine wave? So you say sine. Then you can set the frequency, and you set a value at a current time. And this is a straight up Hertz number. So like 440 is A4. It's the first A key, or it's like the middle A key. So you go to middle C and you move over to A. That's A440. And then you connect it to a destination like your speakers. You hit start, and then you can stop it. So I have this code that you might be looking at. I'm just going to hit enter on this. And I don't know if you could hear that. It was super loud in my headphones.
No.
Blew my ear out. Either way, it played a sound tone. We'll have this code in the show notes. You can copy and paste it, throw it into your console, just hit enter, and you'll get a sine wave. And you can see really quickly what in like 6-7 lines of code, you're able to generate a sound using a sine wave directly in your browser with like no effort. And this can be used to do a lot of stuff, to create full synthesizers. That was one of my first projects, was to create a keyboard that played audio synth just based on whatever key I'm hitting on the keyboard, similar to what the project I'm showing you in this podcast, but like for generating synths instead of sending MIDI somewhere else. And that's really great. I think it's really neat. There's actually a really great library that can take care of this as well called Tone.js. Tone.js is super good. It handles like just like WebMIDI.js handles a lot of the nitty gritty stuff, this really just makes it super easy. Play this note, C4, play it now, start out. It's way a nicer API than having to get into some of the nitty gritty of this all, but definitely a cool thing to mess around with if you're interested in actually generating audio synthesis.
Like even another use case, if you're not into music, sometimes in your app, you need to just play a little sound.
Yeah.
Like, for example, if something finishes and you need to play like a little boop or something is incorrect, like if somebody tabs away and you need to play an audio alert that something happened, sometimes it's easier to simply just write, 7 lines of JavaScript to create that little boop and play it versus having to load a whole wave element and then like load it up, play. Because the thing about the audio API and playing audio in the browser is you have to latch onto a click event before you can actually play audio.
Mm-hmm.
So you got to like wait for somebody to like click something, and the first time they click, you got to set it up, and then you can play it later on. So
why is that, Wes?
Nice.
Do you want to explain to the audience why that is?
Well, you can't just autoplay audio on websites because it's just the same with video, right?
Yeah,
autoplaying those can be extremely annoying. So you have to do it. There's a whole, maybe we should do a little show on that, like on what makes you allowed to autoplay, because some websites can, and there's like a algorithm that goes into whether you're allowed to autoplay audio or not.
It's honestly kind of a mysterious algorithm. So super interesting.
It's just math, but yeah.
Well, no, that's you know what, Wes? Sometimes math is mysterious.
Yes, that's true.
Yeah, what's interesting is that the browser also takes care of like sampling audio. So those of you who don't know too much about how digital audio works. So let's say you have a record, like a vinyl record, and you're playing that record. That is actually playing a straight, continuous waveform, right? That's playing just straight up, why it's called analog audio, right? It's playing just a straight up waveform. Where the difference between analog and digital, and it's some of the reason why people say they like their records better than their MP3s, is because when you have an MP3 or you have a digital audio file, kind of inherently what it's doing is it's sampling the audio. So every X amount of milliseconds, it's taking just a single chunk of that waveform. So you can imagine like a smooth waveform suddenly becomes like stepped blocks, right? And the amount of stepped blocks, how finely you chop that up, we're chopping carrots here. How finely you chop that up is what's called the sampling rate. So the higher the sampling rate, the more close it is to analog audio, and the better it's going to sound. But also the larger this audio form is going to be, the more data it is, right? Because you're sending way more data every single time you have smaller chunks. So that's a big reason why people say digital audio doesn't feel as good as analog audio, because analog audio is not losing any information, where digital, you have to chop it up. So like, if you zoom in close enough, it's always going to be stepped. It's always going to be chopped instead of a smooth, continuous waveform. So if you ever hear sampling rate, that's what that's doing. You can control sampling rate in the browser in an audio buffer. So if you're sending audio over, over WebRTC, you're sending audio to somebody and you want it to send less data, what do? You lower the sampling rate. The audio is going to sound tinnier. It's going to sound more hollow. It's losing some of that information, but it's going to be much smaller, right? So that's one of the reasons why, when you record or we do this stuff, we want to record locally to get the best sampling rate instead of whatever we have to send over the network for Wes to hear, or vice versa. Yeah. So yeah, you can control sampling rate directly within the audio buffer just by changing the sampling rate. Pretty neat.
I just found another project from Phil Miller. He's the dev behind Domino, DMNO, doing like some like secret stuff. I just randomly found a project by him, which was WebRTC and using WEBMIDI.js. So being able to play your MIDI things, but with friends. And instead of sending audio to friends, you're sending MIDI data, and then you're just reproducing it on the person's machine. So like that's not a lot of overhead at all.
I was thinking about doing that same thing. So that's interesting to know that somebody else is on that.
That's so cool.
Yeah. I know I was thinking about like how you could have a multiplayer MIDI workstation, or even you're recording MIDI in the browser multiplayer or something like that could be really super interesting. I'm going to check this project out. That looks really super neat. I should have actually looked before we recorded this. So I was just like, oh, I want to make that.
No, sometimes you have an idea and it's like, I don't even want to look if somebody's done this because I'm so excited about learning and doing it. Is I don't want to be like, someone already did that, or I don't want to see how they did it, because I love the process of trying to figure out how to do it myself.
Yeah, that's actually like a lot of what inspired this keyboard that I made for myself, because I got an ad. I got served an ad for a synth created by, or a MIDI controller. I don't even know if it has synthesis on it. I think it's a MIDI controller from Tame Impala. There's a band, Tame Impala. They created their own idea generator synth. I don't even know what they're calling it. Regardless, it's sold out. They had like a limited number of them, and it does exactly what mine does, where you can hold one button to do keys and hold another to modulate or play arpeggios inside of a chord, or strum them, or do all kinds of stuff. And I went to look at it. I was like, oh, that sounds neat. I would love to own that. And then there's like, oh, we had a limited amount and it's sold out. I'm like, you know what? I'm going to build it in JavaScript. So I had a buddy of mine message me on Instagram, and he was like, hey, did you get inspired by the Tame Impala synth to do this? And I was like, oh, yes, I did. That's definitely what I'm doing. I'm recreating it.
One more neat facts. All right, keep just interjecting on the show.
No, neat facts. I love it.
But this is my app where I built the dialer.
Oh.
And it wasn't working earlier, and I was just debugging it a second, and it says like an audio context is not allowed to start.
Yeah.
Because it has to be attached to a gesture, right? We just talked about that. You have to click first. But guess what is considered a gesture on Safari on iOS?
Could it be like the accelerometer?
No,
it's
I
don't know.
The mute button on the side. I couldn't figure out. I'm like, it was working, now it's not. And so I I had my mute button off. And I turned it off, and then I turned it back on again, and then that was enough to consider it a gesture. And now Safari lets you play the audio, which is awful.
You know what doesn't need a gesture is the MIDI API. So that means like you hit a key and it would still register the MIDI event, and that considers it a gesture. So maybe you could start audio synthesis then. I don't know. I haven't even tried that.
Yeah, you have to wait for the first user input. Whether that's like hitting enter, or I'm curious what the gestures are considered now.
Yeah.
That's a browser level implementation, but clearly flicking the mute button on the side of an iPhone 13 Pro Max is enough of a gesture to allow it.
Yeah. I guess that gets us into the last little bit here, which would be the media recorder. Now, we're not going to spend a ton of time, but media recorder, as far as web audio APIs go, is really great for a lot of reasons. Like potentially you could be just building a simple recorder where it's connecting to your audio source, your microphone, you're talking into it, you can record that. You create a new recorder and you pass in data into chunks. And then once you're done, once you stop the recording, you can then create audio directly in the browser, and it's pretty amazing. Like I can essentially record audio directly in the browser, save it as a file, and then download that file directly entirely in the browser without any additional software, just using the Media Recorder API. So, man, so much cool stuff in these APIs that I feel like are fairly underutilized, whether that is the media one, the audio API. So much cool stuff here, and that's not even getting into like WebRTC or any of that cool stuff that you can do there. So a lot of interesting things you can do. If you're a music person or just curious about any of this stuff, spend some time just diving into the MDN docs. We'll have a link in the show notes, or fire up Tone.js or WebMIDI.js and experiment with this stuff, because this is the type of thing that when I work on it gets me super inspired to make fun things rather than I'm just pushing pixels on a website. No, this is like, I'm creating music. I'm making something that has actual sound. I'm something that I can show my kids. Hey, push this key. How does this sound?
Yeah.
Oh, now push this minor note. How does that sound? Like I could use these as educational tools. So very interesting.
If you're feeling at the very least burnt out on coding, putting buttons on screens and clicking them and updating databases, try hook up a friggin' keyboard or a Roomba to your browser. That's really fun. And it will ignite. Not to say that I'm burnt out. A lot of people thought that on my video, but I always recommend people to do creative coding and go outside of your regular button clicking, because it makes you so excited about web development in general.
Yeah, imagine this, right? Here's some freebie project ideas. Like we talked about sending and receiving messages or data or audio or stuff like that, or generating them. You can use that information in all sorts of cool ways. Like, what if you took the MIDI message, I hit a specific note, and that note controls the background color on the website? That's a fun little project right there. I hit this key, it changes to this color. And you could just, clamp the notes on a scale to the range of RGB colors and, have some fun really just doing something expressive or creative. Or I got a MIDI drum set. I'm going to go downstairs, I'm going to hook the MIDI drum set in, and I'm going to have elements on my page enlarge in size based on how hard I hit the drum. That sounds like a ton of fun to make some of this stuff. So if you have any MIDI devices around, you can experiment with these. Otherwise, the audio synthesis API, I have this crappy little MIDI controller that's probably like $60. You can get them for super cheap. I got this just simple little MIDI slider off of Etsy for like $20-$30. You can get all kinds of cool stuff out there to control MIDI and use that just for fun projects. Who cares? Build some art.
You can just make art.
Yeah, you're allowed to just make art.
Awesome. That was awesome. I can't believe how much of a well these APIs are sometimes, right? It's just one or two little APIs in the browser, and it goes all the way down, and it has such history as well.
Yeah, totally, right? So cool. Let me know what you think. If you're building anything like this, let us know. I will make my synth available, or my MIDI controller, my in-browser MIDI controller available. But just to let you know, it does not generate sound on its own. You need to pipe it into a digital audio workstation, at least right now. I don't feel like doing audio synthesis in it is like what I want to use it for, because whatever VST inside of Ableton or whatever I have is going to sound way better than anything that I could make myself with, the web audio API. So either way, I'll make that available. We'll have a link in the show notes if you want to check it out. That code will be open source too, if you want to see exactly how I did it. As always, let's get into sick picks and shameless plugs. Wes, what do you got for sick picks and shameless plugs?
Yeah, I'm going to sick pick a little microcontroller. This is the one that I used to program my Roomba. Actually, this is one that I'm playing with a little bit of these LED arrays right now. But these things are extremely fun to work on. They're a little microcontroller that has Bluetooth and Wi-Fi built right into it. You can power them via USB. You can power them via several other ways. They're $5, which is unbelievable. There's lots of projects out there for home automation. There's lots of projects out there for LED. WLED is one that runs on it, and it's a really fun thing. Like if you're trying to tinker and get into electronics, for probably for $10, $5 for the controller, $5 for some wires and whatnot, you can start building some pretty fun stuff with it.
I'm very interested in this WLED. Are you doing stuff with pushing visuals to an LED panel?
That's what I'm working on right now. So I've used WLED for the mirror in our gym. So when I built the mirror in our gym, I put LEDs behind the entire thing, and then it can do cool effects and kind of backlight the mirror. And then my on air.
Mm-hmm.
There we go. That is a sign that says on air, and I just gutted it and put a ESP32 and some LED strips in it, and I can control that however I want. But now I'm dipping into these LED arrays.
That's what I want right there.
I'm trying to figure, how sick would that be if we built a website where you could just draw on the website and it would in real time paint to LEDs?
Yeah.
So that's my idea, at least. It's a lot of LEDs though, so the powering them is a bit of a thing I got to figure out yet, because it's not just it's a lot of power that these things take. If you have them all at full cook, you need like a massive power supply or several
Really?
of them. So I
Really?
gotta dip into that. Yeah.
Wow. Yeah, that's interesting, man. I'm fascinated about that stuff. Let me update or give me an update on that once you're cooking a little bit more. I'm
Yeah.
super interested.
Yeah, you should just order a couple of these and at least like get it running so you can kind of get in the headspace of it, because I bet you can probably get it up and running in like 23 minutes. You flash the microcontroller in the browser. Like, you don't even have to download like an IDE or like install Python or any of that. You literally visit a website, plug it into USB, and it flashes it from the browser, it's using the Web Serial API. It's unbelievable.
Man, cool. Man, you do the coolest stuff sometimes. Awesome. So my sick pick is going to be, I have, after what? Many years working in computing on computers, I have finally given in and gotten a mouse. That's right.
All right.
I never work with mice ever. I'm a trackpad guy. I'm super trackpaddy. And I love my trackpad. Yeah, we're Costco. But you know what? When I broke my finger, the trackpad was giving me all kinds of RSI. I'm like, now's the time. I'm going to get a mouse. I got the Logitech MX Master, the S3, 3S.
Yeah, that's what I have as well.
And I gotta say, the coolest thing about this mouse, besides the fact that it's just nice and comfortable and all that, the software that Logitech made for this is crazy good.
Yeah, it's actually pretty good.
You think you got to get into, some third party to do some crazy stuff, but I didn't realize this, Wes. You can set every single button on this thing to respond to gestures. So every single button you could hold and move the mouse in a direction, and it would trigger a different piece of functionality. So I have
and do it per app as well.
I have it so like if I hold essentially there's the back and forward buttons are typically what they are. I have my forward button. If I hold that and hit to the right, it does paste. If I hit to the left, it does copy. And I've been just copying and pasting that way, and it feels so natural. It's crazy how natural it feels once you get used to all of like your own predefined setup. So yeah, I'm impressed. I'm impressed with the mouse, but I'm equally impressed with the software that this thing came with. So shout out to Logitech for making something that's actually extendable and like customizable out of the box. If you're a tinkerer, this thing's a tinkerer's dream. I just have been going nuts with customizing this thing. So I know I'm super late.
Cool stuff.
Yeah, very late to the party.
GitHub Universe. They're like half going after like the gamer market, but like as soon as I ordered this thing, every single gamer, I did a TikTok on it, and every single gamer comes out of the woodwork being like, oh, it's not fast enough refresh rate, and like all this, like I find it lags quite a bit when I'm killing noobs in my game, and it's like I'm not gaming with this thing. I'm clicking on buttons and like highlighting text, and it's a totally different world when you're like targeting like web developers who don't necessarily, they care more about ergonomics and productivity than they do like refresh rate or something like that.
Neat stuff. Logitech. Shout out. Shameless plugs. Head on over to YouTube. CJ released a crazy good video on the most starred projects in JavaScript in 24. Man, what a banger of a video. So check that out. We'll link it available in the description of the show. It's really fascinating because it's not just like, here's a list of the top 15 most starred projects. It actually breaks down like why. It gets into what they did and why they had the year they had, or why people cared about it this specifically in the last year. And it gives you a lot of context to where we are today in 2025. So well worth your time. I learned a lot from it. So shout out to CJ for putting that together.
Sweet. It was a very good video. All right. Thanks everybody so much for tuning in, and we will catch you later. Peace.